Hi, this is Alex from devstories.eu. SunPy Solar Data Analysis, Episode 10 of 12. Just because two different instruments take a picture of the sun at the exact same second does not mean their pixels line up. Overlaying them directly will give you a misaligned mess. Aligning and reprojecting maps solves this. When comparing data from the Atmospheric Imaging Assembly, or AIA, and the Helioseismic and Magnetic Imager, or HMI, both instruments sit on the same satellite. They capture images simultaneously. A common mistake is assuming that these two full-disk images can be directly overlaid just because the timing matches. But instruments have different plate scales, meaning their individual pixels cover different physical areas. They also have slight pointing offsets. If you take a high-resolution extreme ultraviolet image from AIA and a lower-resolution magnetogram from HMI, their grids simply do not align. Say you want to plot the magnetic contours from the HMI data perfectly over the coronal loops in the AIA image. To do this, you must cast the HMI data into the World Coordinate System, or WCS, of the AIA map. The WCS is the mathematical framework embedded in the map that translates a pixel location into an actual physical coordinate on the sky. SunPy handles this transformation through an external package called reproject. You use a function named reproject_interpol. This function performs fast spatial interpolation, which is the necessary approach when you are aligning standard solar imaging data. First, you define your target. In this scenario, the target is the AIA map, so you extract its WCS object. Next, you pass your source map, the HMI magnetogram, and that target WCS into the interpolation function. The function projects the target grid onto the source data. It calculates where the new pixels sit in physical space, queries the original HMI map at those precise coordinates, and interpolates the pixel values. By default, the function hands you back a new raw data array shaped exactly like the target image alongside a footprint array. The footprint indicates which pixels fell outside the original field of view. Since you only need the data for the overlay, you can pass a parameter to ignore the footprint entirely, which returns just the interpolated array. To make this raw array useful, you construct a new SunPy map. You pair your newly interpolated HMI data array with the metadata header of your target AIA map. Here is the key insight. Reprojection mathematically guarantees identical spatial grids. Your new HMI map now has the exact same dimensions and plate scale as the AIA map. Indexed 500 by 500 in the newly aligned map corresponds to the exact same physical solar feature as indexed 500 by 500 in the AIA map. You can now plot the AIA image on a set of axes and confidently draw the magnetic contours from your aligned map directly on top. Because reprojection permanently alters your original data values through interpolation to force a coordinate match, always perform this alignment step last, right before your final visualization or array math. Thanks for spending a few minutes with me. Until next time, take it easy.